Hello everyone, we have already discussed the lattices. So a poset is a lattice if it is both joint semilattice and meet semilattice. Now we are going to discuss the properties of lattice, then sublattices, distributive lattices and complementary lattices. So in the properties of lattice, let L be a non-empty set closed under two binary operations called meet and join, denoted respectively by the symbols. Then L is called a lattice if the following axioms hold where A, B, C are elements in L. So meet is greatest lower bound and join is least upper bound. So we have commutative law like A meet B would be equals to B meet A and A join B would be equals to B join A. Then we have associative law like A meet B meet C would be equals to A meet B meet C, and same for join. So you can verify this from this lattice. So A meet B would be, so greatest lower bound, so A meet B would be A, then A meet C would be A, then B meet C would be A, then A meet A would be A. Then we have absorption law like A meet A join B equals to A. So A join B is least upper bound. So A join B is B. Then A meet B would be A. You can verify this also. We have sublattices. Suppose M is a non-empty subset of lattice L. We say M is a sublattice of L if M itself is a lattice. So we have this lattice. We have the elements X, A, B, C, D, E, Y. Then we have sublattices L1, L2, L3. So you can check this X, A, Y, B, L1. So this is the sublattice X, A, B, Y, which is itself a lattice. Then L2, X, A, C, Y. This is a sublattice. Then L3, X, C, D, Y. This is a sublattice. Then there may be a case when the subset is a lattice and the actual set is not a lattice. So this is the case. This diagram is not a lattice, but A, B, C, D subset is a lattice. We have bounded lattice. So a lattice L is said to have a lower bound O such that for all A is in L, O relates A. L is said to have an upper bound I such that for all A is in L, A relates I. So lower bound is like minimum element and upper bound is like maximum element. Some books it is represented by 0 and 1. So lower bound is 0 and upper bound is 1. We say L is bounded if L has both a lower bound and upper bound. In such a lattice, we have the identities like A join I would be equals to I. So here A is lower bound O and D is upper bound, that is I. So A join D would be least upper bound, so which is D, and D is the upper bound. Then A meet I would be equals to A, so A meet D would be greatest lower bound, so this is A. We can check for this. A join A would be A, then A meet A would be A. So every finite lattice L is bounded. We can find complement of an element in a lattice also. In a bounded lattice L, for any element A belongs to lattice L, if there exists an element B belongs to L, such that A join B equals to upper bound I and A meet B equals to lower bound O. That B is called complement of A, or we can say A and B are complements of each other. So complement of universal set is phi and complement of phi is universal set. Then complement of upper bound is lower bound and complement of lower bound is upper bound. So here in this lattice we have the elements A, B, C, D, and we have the lower bound A and upper bound D. So A and D are complements to each other. Then let's check for B and C. So B join C is D. Then B meet C is A. That's fine. So B and C are complements to each other. Then in this lattice we have the elements A, B, C, D, E, F, G. So for the pair BC, so B and C are complements to each other because B joins C is G and B meets C is A because A is lower bound and G is upper bound. Then let's check for pair B and F. So B join F is G and B meet F is A. That's fine. So B and F are complements to each other. Then again C and D are complements to each other. Then C and B, obviously B and C we have already checked are complements. So B has two complements C and F, and C has two complements B and D, and D complement is C, then F complement is B. So complements need not exist and need not be unique. So there may be an element which does not have any complement, and there may be an element which have more than one complement. We have distributive lattice. So a lattice L is said to be distributive if for any element ABC in L we have the following distributive law property. So a lattice is distributive if it follows the distributive law. So we have elements ABC, then A meet B join C equals to A meet B join A meet C. So we have to check for all the elements, like we have the lattice A B C D E. So let's check for the ABC elements. Then A join B meet C equals to A join B meet A join C. So this should be equal. So B meet C is D, that is greatest lower bound. Then A join B is least upper bound is E. Then A join C is E. Then A join D would be A. Then E meet E would be E, but A does not equals to E. So this is not a distributive lattice because it does not follow the distributive law. Here you can see we have BC complement for A. So A complement equals to B comma C because A join B is equals to E and A meet B equals to D. Then A join C equals to D. Then A meet C equals to D. So we have more than one complement for A. Then we have this lattice. So this is a distributive lattice. So you can verify this by distributive law on applying all the elements, but it is not practical way. So if every element has at most one complement, then it is distributive lattice. So this is another way to check whether the lattice is distributive or not. So if every element has at most one complement, that means at most means 0 complement or 1 complement. So there should not be complement more than 1. Like A have two complements B and C. So here C complement is F complement is C, and D complement is B, and B complement is D. But A complement does not exist here and E complement does not exist here, because here A and E are not complement to each other, because A meet E would be A and A join E would be E. So this is not our distributive lattice. So then we have complemented lattice. A lattice L is said to be complemented if L is bounded and every element in L has a complement. So if L is bounded and every element in L has a complement. So every element should have a complement. So this should not be the case that any element does not have the complement. So this is a complemented lattice. So this is not a complemented lattice because the problem arises here D and C. So D does not have any complement and C does not have any complement.